Hello and welcome to yet another installment of the Algebra 1 videos. This is over section 4 and this is over solving rate problems. And our objectives today is we want to use a table to organize information given in time, distance, rate, and work problems. And we want to be able to write and solve one variable linear equations to model and solve time, distance, and rate and work problems. So the first thing I want to do is talk about this concept that you've heard before. And that is that the distance that which you travel is equal to the rate times the time, okay? And that's where, d is equal to your distance, r is your rate, okay? Oftentimes your speed, okay? And then t is equal to time, okay? So what we want to do is kind of look at this situation here where your x-axis is time, okay, so x-axis is time, and your y-axis, okay, is distance, all right, and that's in meters. And what we understand from this is that if you're traveling at a constant rate, then if you can model the distance that you travel based on how long you travel for that distance. So what we have here is we have this point on the graph of 1, 2. So after 1 second, we've traveled a distance of 2 meters, okay? After 3 seconds, we're traveling a distance of 6 meters, okay? After 5 seconds, we've traveled a distance of 10 meters. Now, the reality of it is that I didn't mention one thing, and that's this thing that is 2 meters per second. That is your rate, okay? That's your speed at which you're traveling, okay? And so the other thing, that's a rate. It's also a rate of change, okay? If I were to model the slope of any of these lines, it's 2 over 1. This is 4 over 2. And 2 over 1 and 4 over 2, your slope m is equal to 2, okay? And that's 2 meters, okay, per 1 second. And think about how I get that. When I look at my y-axis, that's a measure of meters. The change in y is meters divided by your time, which is in seconds. And that gives you your speed. So your slope, okay, is the same thing as your rate, is the same thing as your speed. That's your slope, okay? So let's go ahead and take a look at a typical problem that you would see, especially on like an ACT exam or something like that. So if we read through this, it says Marianne drove to a friend's house at an average rate of 55 miles per hour. She took the same route on the way back, and her average rate was 45 miles per hour. If she spent a total of 2 hours driving, how far did she drive in all? Okay, and so here's what we would do. Let's just say this, that the time that it takes, let's just take a look at this table here. Okay, we have our rate in miles per hour. We have our time in hours, and then we have our distance. Now remember that distance is equal to the rate times the time, all right? So here's your r, here's your t, here's your distance, all right? So, we go ahead and we've put in those rates in there, but the question is what's the time frame looking like, okay? Now let's say that as we're doing this, and it just says that the total trip time took 2 hours, okay? That includes the trip to the friends and to the trip home. So what I want to do is just model this and say, well, you know what? I don't know what the time is of the time it took to go to the friend's house, so I'm just going to call that t, okay? Now on the other one, okay, I can't just put that this is a time, but I do know that the total time took 2 hours. So I'm going to write this down, that the total time is 2 hours. So the only way, if I knew how long it took to go to the friend's house, to come home, I'm going to do this. I'm going to call this the quantity 2 minus t. Now here's why. All right, because if I take the time that it takes to go to the friend's house and the time home, it should give me 2 hours. So if I take 2 hours and subtract off the time that it took to go to the friend's house, then that would give me the amount of time that it would take to go home, okay? And these are kind of interchangeable, okay, on whichever ones you can do. It doesn't really matter which one you choose, as long as one of them is t and one of them is 2 minus t, Okay? So what I would do then is in order to get the distance, okay, that it would take, then that means that I have to take the trip to the friend, I have to take the rate, which is 55 miles an hour, and multiply it by the time, okay? And so my distance would be 55t, okay? And the same thing with the trip home. I would take the rate at which you travel times the time, okay? And I'm just going to write that as 45 times 2 minus t. Now, here's the thing, okay? What we want to do is we want to write a linear equation and use the properties of equality to solve for the total distance. So how far did we go? So what we want to do is be able to figure out and solve this for t. Now, what I know is that the distance that you traveled to the friend's house is equivalent to the distance that you would travel home. So these two are equal, okay? So because those are equal, I'm going to set up an equation. I'm going to say 55t is equal to 45 times 2 minus t, okay? And I just want to solve this for t, all right? So I'm going to multiply through my 45, and so I get 55t is equal to 45 times 2 is 90 minus 45t, okay? So then what I'm going to do is I'm going to solve for t. I'm going to add 45 to both sides, add 45t to both sides, and what that's going to give me is going to give me 100t, okay, and that's going to equal 90, all right? So then if I divide by 100 here and divide this by 100, okay, I end up getting that t is equal to 9 out of 10, okay, which is 90 out of 100, 9 out of 10, which is equal to 0.9, and this is 0.9 hours, okay? So, but we have to still go back and answer the question because it says, what's the distance, okay? I know the time that it's going to take me, all right, to go to the friend's house, okay, 0.9 hours. Then what I'm going to do is I'm going to solve that for the actual distance. So to find the distance, okay, I would take that value and plug it into here. You could plug it into here as well if you want, but this one seems like it's a little bit easier. So to find our distance, I'm going to take the rate at which we travel, which is 55 miles an hour, and multiply that by 0.9 hours, okay? And so my total distance then is going to be 49.5 miles, okay? And that's all you're doing, okay? It is kind of tricky to set these up, but, we have to use a table and we have to use our knowledge of what distance is equal to rate times time is to be able to figure that out. So, okay, so let's take a look at another one, okay? And it says that Stu hiked a trail at an average rate of 3 miles per hour. So, all right, let's continue reading this. He says it ran back on the same trail at an average rate of 5 miles per hour, okay? He traveled for a total of 3 hours, okay? So the question is, okay, what's the distance of the trail, okay? What's the distance of the trail, okay? And so let's go through this. And what we know is that, Stu hiked a trail at an average rate of 3 miles per hour. So that's the trip to the end of the trail, okay? So that's going to be 3 miles an hour, all right? And then what we also know is that the trip back, okay, he ran back on the same trail at a rate of 5 miles per hour, okay? Now, what we know is that it took a total of 3 hours to do the whole thing. So that's, I'm going to give some time going there, all right? And then I'm going to do 3 hours minus the time going there on the trip back. So now what we need to do is need to figure out the distance. So I'm going to multiply my rate times my time. So my distance is 3t, okay? On the trip back, I'm going to multiply my rate times my time, and that's 5 times 3 minus t, all right? So what I know about these two distances is that they're equal, okay? You're just traveling faster on one than the other. So let's go ahead and set these two equal to each other. So I'm going to do 3t is equal to 5 times the quantity 3 minus t. Okay, so I'm going to multiply throughout my 5, and so we're going to get 3t is equal to 15 minus 5t, okay? And so then what I want to do is add the 5t to both sides. Add the 5t. And so then we get this. We get 8t is equal to 15. Okay, and if I divide by 8 and divide by 8, then I get that t is equal to, and 15 divided by 8 is going to give us 1.875 hours. Okay? And so what we want to do is we want to figure out, well, what's the total distance traveled? What's the distance of that trail? And so if I take, I want to find my distance, then I'm going to take 3 miles an hour times 1.875 hours, and that's going to give me a total distance of 5.625 miles. All right, and that's it. So it's really similar to the last one that we did, and just got to do the same thing, do what it's asking you. Okay. Now let's go ahead and look at the last one, and this one is a standard ACT question, so I do want to go over this. And it says that a train heads west at 80 miles per hour, and another train heads east on a parallel track at the same time, traveling at 70 miles an hour. Okay, the train conductors can see each other when the trains are 1.5 miles apart. If the trains start 63 miles apart, how long does it take for them to see each other? Okay, so here's what I want to do. Let's come in here and let's draw a line here, okay, just to kind of show, from one starting point to the other. And I know that this is 63 miles, okay, and I know that one train travels a distance. So we'll call this train A, and this is going at a rate of 80 miles an hour, so 80t, okay, 80 times, so the rate at which you travel, all right, times the time, and that gives you a certain distance, okay, certain distance traveled, okay. The other train is traveling in the other direction at 70 miles an hour. We'll call that train B, and it's going this way, traveling at 70t, all right, and that distance is right here, okay, travels a certain distance, such that the distance in between them is 1.5 miles. Okay, so what we want to do, and they leave at the same time, is we want to figure out how far does it take them both to travel 61.5 miles. Okay, and the reason why I got that is because of the of taking 1.5 miles and subtracting it from 63. So let's do something here. Let's make a table. Okay, and I'm going to make a one for the rate, and then the time, and then the distance. Okay, and so what we know here is that, okay, let's do this, and let's call this train A, all right, and this is train B. Okay, and we know that the rate at which we travel on train A was 80 miles an hour, okay? And we know that for train B, they were traveling 70 miles an hour, okay? And so then the time is the same for both, okay? They leave at the same time. We want to know at what time do they see each other. So I'm going to put T for both of these, okay? And what I know is that what we have is that if we take the rate times the time, that gives us the distance. So this is going to give me 80t, and this is going to give me 70t. And that's how I got 80t and 70t in the first place, okay? But what I want to do is make the realization that if we add these together, and if we add, then we equal 61.5 miles, okay? So what I want to do is set up an equation and take 80t plus 70t, add those up, and that's going to give me 61.5, okay? And so if I do that, okay, I'm going to combine my like terms. I get 80 plus 70t, which is going to be 150t, and that's equal to 61.5. Okay, and then I'm going to divide by 150, okay, do that on both sides. And so then I get that my time is equal to 0.41 hours. Okay, and that's how long that those trains would have to travel in order to get to be able to see each other. Okay, and that's how long it would have to take. So, just use what you know, set up an equation, and solve. This one, and some of these are pretty hard, but, the more we do for practice, the better we're going to get. Okay, on this next part, what I want you to take a look at is working with your units. Okay, now when I do this, when I'm trying to find the total distance, I do this. I know that and I write my rates like this. I say that my distance is equal to the rate, which is 3 miles per hour. So this is 3 miles per 1 hour, okay? And I multiply that by 2/3 of an hour over 1. And when I do that, my units divide out. If I take hours and divide it by hours, I get nothing. And I'm left with a measure of miles. Okay, so then my distance is equal to 3 times 2/3. My 3's divide out, and you're left with 2 miles. Okay? And so, that sounds pretty reasonable, right? If you're traveling 3 miles an hour, what that means is that for every hour that you travel, you're going 3 miles, okay? Now, the same problem over here is the same thing, except for we're dealing with miles per hour, and then we're dealing with minutes, okay? So when you have something like that, if you were to take this and you were to just do d is equal to 3 times 40, then that means that you're traveling 3 times 40 is 120 miles. And that doesn't really make any sense, okay? So this doesn't make sense, all right? And so, and the idea, guys, is that you want to change 40 minutes into hours, okay? And the way I do it is I do this. I do 40 minutes, okay? And then I think about, if I wanted to put that into hours, okay, I put that over 1, and I multiply that by 1 hour over 60 minutes, okay, and use my conversion table. And I know that my minutes are going to divide out, and so you're left with 40 over 60, okay, which simplifies down to 2/3 hours, okay. So, you got to make sure that we're working in the same units and that we're not getting confused, okay? And just kind of make sure, does the problem make sense, okay? So now let's take a look at a work problem. And in this work problem, it says that Nate and Roger are painting a fence. Nate can paint the entire fence in 4 hours, and Roger can paint the entire fence in 5 hours. How long would it take them to paint the entire fence if they were working together? So the first thing I want to do is, what we want to do is model all of this using, a table. So we've got the rate and the time, and then the part of the fence painted, okay? And we have, this option for Nate and for Roger. Now what I know, and I'm going to zoom in over here, I know it takes Nate 4 hours to paint the fence. So the question is how much of the fence could he paint in 1 hour? Okay, how much the part per hour? And so what this comes out to, the rate, all right, is going to be 1/4 of the fence can be painted in an hour. Okay, and the same thing with Roger. Okay, Roger can paint the fence in 5 hours. All right, so the rate at which he can paint the fence, he can get 1/5 of it done in an hour. Okay, so I'm going to come over here. And for the rate, for Nate, I know this is going to be 1/4. And then for Roger, this is going to be 1/5. Okay? And then the time that it takes them the same amount of time. Okay? So if the time that they take to work together is the same, then the time is just t here and t here. Okay? And I'm going to multiply the rate and the time together to get the amount of the fence, the total amount of fence that's been painted. So in this column, I get 1/4 t, all right? And in this column, I get 1/5 t, okay? So now we want to set up an equation and solve for t. So what I'd want to do is this, what I'm going to do is I'm going to write 1/4 t plus 1/5 t. If I take the part of the fence that's been painted by Nate and part of the fence that's painted by Roger and add them together, then I'm going to get one whole fence that's been painted. Okay? And so, it's just one of those things that we, this is the standard equation that we write. Okay? Now, the question is coming up and figuring out how to solve this for t. So I'm going to zoom in so I've got some bit of space to write this. But I'm going to go ahead and multiply these two together. And when I do that, I'm multiplying these, and t is over 1. Okay, so I'm just going to multiply across. And 1 times t is going to give me t. 4 times 1 is 4. Okay, and then same thing over here. This is just going to be t over 5, and then this is equal to 1. Okay, now what I want to do here is, and there's a number of ways you can do this, but what I want to do, one of the things that I can do, okay, you can solve this a number of ways. I'm going to try and give you guys the easiest way. I'm going to multiply this equation by the common denominator. And the common denominator, and I'm going to write this out over here, the common denominator is 20, okay? And I got that by taking 4 times 5, okay? And that's always going to work. If you take the denominators and you multiply them together, you get a common denominator, and then you can multiply the entire thing by that common denominator, and you can multiply that through into each of those pieces. So you get this. You get 20 over 1 times t over 4 plus 20 over 1 times t over 5 is equal to 20 times 1, which is just 20. Okay? Now what happens here is that the 20 divides out the 4 into 5 over 1. Same thing with the 20 over 5 that divides it out into 4 over 1. So we get this. We get 5t plus 4t is equal to 20. All right? And so let me write this out up over here. 5t plus 4t equals 20. So 5t plus 4t is equal to 20. So then 5t plus 4t gives me 9t, and then that is equal to 20. And if I divide both sides by 9 and by 9, okay, if I take 20 and divide it by 9, that's going to give me 2.2 repeating. So my time frame is 2.22 hours, basically, okay, if we rounded. All right, and you could even say that the time that it takes was 20/9 hours, same thing, okay? But that's just an equation we can set up to solve that for t, okay? Now let's go ahead and take a look at another one, okay? It says a medium water hose can fill a pool in 30 minutes, okay? A large water hose can fill the same pool in 20 minutes. If both hoses are turned on at the same time, how long will it take to fill the pool? So what I know is that the medium hose, the rate, is going to be 30 minutes. Hold on. So parts per minute. So we can fill the pool, okay? And the question is, how many parts per minute can we do? It takes 30 minutes to fill the pool. So I'm going to write this as, I'm going to zoom in. This is 1 over 30, okay? 1/30 of the pool can be done in 1 minute. And the large hose can do it in 20 minutes, so 1 out of 20. Okay, if they work for the same time, okay, T and T, then the part of the pool that's filled is T over 30, and here this is T over 20. All right, so what I want to do is set up an equation, and that's going to be T over 30 plus T over 20, add those together, and that's one whole pool that's been filled. All right, so now what I want to do is multiply by the common denominator. So common denom, and that's 60. Okay, so if I multiply this whole thing by 60, okay, I'm going to multiply it through. And so if I get 60 over 1 times T over 30 plus 60 over 1 times T over 20, then that's going to give me 60 times 1, which is just 60. Okay? And so when I do this, all right, I know I can divide out the 60 and the 30 to 2 over 1, and that's just going to give me 2t. Okay, if I divide out 60 and the 20, that's 3 over 1. That's just plus 3t. and then this is equal to 60, okay? And then, okay, if I add these together and combine like terms, I'm going to get 2t and 3t give me 5t, and then that's equal to 60. Divide by 5 and divide by 5. So then the time that it takes is equal to 12 minutes, okay? And that's it, okay? That's all we're doing. All right. I'm going to go ahead and let you guys work on this last one, okay? And that's going to conclude this video, and I'll just go ahead and you guys get started on the assignment and then get started on the quiz. Thank you. See you in a bit. Bye.